Good morning. My name is Mike McVeigh. My company is Paramount Geothermal. Thanks for watching this video today. Today, we're going to show you the installation of a geothermal heating and air conditioning system for this home in Vero Beach in Florida. This system is going to use a pump and inject geothermal source well, and it will provide all of the primary energy for the system to provide air conditioning and heating for this home. It also will provide the heating for the swimming pool year-round. This system will replace 3 existing conventional split units, air-to-air units, 5-ton, 2.5-ton, and a 2-ton. We'll be using integrated units that will all be indoors to eliminate the outdoor wear and tear on the equipment. And we'll be putting in a geothermal pool pump. This is the front entrance of the home. The garage is over here to the side. And from the garage side of the house, over through the courtyard area and the outdoor existing air conditioning and pool heating equipment, we're going to be putting a pump about where I'm standing, with lines running about where those 2 white pipes go. That will be the pump well. We'll provide water over to the equipment deck, and then we're going to run about 60 feet away at a 90-degree angle down the back of the yard a second well. This is the existing AC equipment. There's a 5-ton compressor and a 2-ton compressor, and that's the pool heater over there in the corner. These units, typically outdoors here in Florida, will last about 5 to 7 years for conventional air conditioning units. The geothermal units, all the equipment will be indoors and should easily last well over 20 years, as will the well and the well equipment, perhaps the pump 10 years. Here we have Bechtel well drilling in Vero Beach. We're starting with the injection well. That well is going to be basically 4-inch casing, and we'll do a drop, 2-inch PVC drop down to 40 feet. We're going to need about 35 gallons a minute of water through this, back into this well, and of course out of this fly well. Here we're just starting the bore of the well itself. It's an 8-inch bored bit that will put a 4-inch casing and pack that nice route around it when we're ready. We drilled a 65-foot injection well deep with an 8-inch borehole drill bit. They're now putting the well casing in. They already dropped the first section, which is the 4-inch piece towards the bottom. You can see with that red band near the ground. That actually has little perforated slots around the edges, so it's a screen. It allows the water to filter through without pulling in debris and rocks and things. So that pipe will drop down about 60 feet.
Yeah, I get it. I get it. That's a good advertising for you. Now you're going to freeze.
And 2-inch PVC will be buried in the ground. Done a lot of heavy lifting trenching here to be wide enough for all the PVC pipes that go from that pump well over to the equipment platform over there. The units that are currently standing there will be gone. So they come from the pump well, follows the side of the house to this trench, under that little sidewalk. We'll go through the wall where you can see that hole, and then on the inside of the garage wall we'll go up the wall and into the attic to bring the water into the heat pumps, and then they will return through the same lines through another pipe, return line, back through the trenches, back up through this pipe, and then all the way back to the injection well, which is over there. Here we've pulled the 5-ton outdoor unit out. It's laying there on the lawn. And in this back corner here is the new AquaCal pool heater. It is a 5-ton, of course, geothermal unit. And we're getting her hooked up and should have that running shortly. Say hey, John. Hooking up the second unit. This is a 2-ton Climate Master Tranquility. And we're just getting it hung up, getting ready to plumb it, and making good progress. Lens cover is closed. That would help.
Garbage. The last of the Mohegans. Here we go. We're done.
Here we have the storage tank for the desuperheater unit that's running off the 5-ton unit. This system has an on-demand gas heater that draws water out of the storage tank, which is heated. Ideally, when the heat pump's running enough, the gas heater won't run at all. And times when it's not running quite often enough, it will pick up slack, but still operate much more efficiently. We basically had a bit of a manifold here where we bring the water in through 1 inch all the way to the 5-ton unit, in and back to from the pump and to the inject well. And then we have the red and green PEX. Green PEX brings water to supply the 2.5 and 2-ton. The red returns it. So then we basically ran them up, and we'll cover this with a chaseway. And we're wrapping up the job. We've got all 3 units running. They're working great. The pool's working great. We have a full-up geothermal system that will heat the pool for probably a quarter of the cost of the propane that it used to use. So hopefully the homeowner will get a lot more use out of it since it can be nice and warm. And the air conditioning units are measured at an EER of about 26, which is probably about 4 times more efficient than the old units that had been out there for a bit and typically do run out and fail in about 10 years. So geothermal life cycle cost is cheaper than conventional systems. Costs a little more up front. Is eligible for the 30% tax credit, which helps a great deal. And the pump and inject system, especially for larger systems like this one, about 15 tons, up to as high as you like to go, the pump and inject system is clearly more affordable than either horizontal or vertical closed-loop systems. So very happy with this system. Very pleased and grateful to the homeowner to give me the opportunity to do this job. So on to the next one.